Alrighty, let's take a look at this question. We have Chantel on a platform of a station, that's point P that I wrote there, 30 meters from the train tracks, and the train is moving away from her at a constant speed of 35 kilometers per hour. So I drew kind of a situation here. We've got this P where she's standing, and then she's 30 meters from the track. That will stay constant, so we would want to label that as a constant. Um, on this is a related rates question because you see things like kilometers per hour and that. Um, on this diagram, if it changes, you need to label it as a variable. If it stays the same, it would be a constant. So the train would be moving, let's say this way, and that means this distance from here to here would be changing, and I'm calling that A. And then the distance between her and the train is changing. We call that C. And that forms a right angle triangle, which we'll get to in a minute. Okay, time to name those derivatives. So a train is moving away from her at a constant speed of 35 kilometers per hour. That distance would be the distance of A on my diagram changing at 35 kilometers per hour. It'd be positive because it's increasing that distance. Determine the rate of change in the distance between Chantel and the train. So we're going to call that dc dt is a question mark, and the moment in time would be when Chantel and the train are 50 meters apart, which means when c is 50 meters. All right, so when we go to set up the equation, we need to relate the variables in the derivatives somehow in an equation to each other. And the easiest on this one would be to do Pythagorean theorem. So c squared equals a squared plus 30 squared. That stays constant, so we label it with a constant. And we're just going to dive in and do the derivative implicitly. Derivative of c squared, 2c, dc dt. Don't forget the chain rule on that. And 2a dA dt. And the derivative of 30 squared, a constant, would just be 0. All right, I'm going to divide both sides by 2 because I notice a 2 in front of both of those, so that's gone. And now we want to sub in our values. We have c, so that can be 50. Awesome. dc dt is what we're looking for. And on the right-hand side, we don't have a. So when that happens, we're just going to draw a little snapshot in time of when that moment that we're concerned with happens. So we've got 50, we've got 30, and then we're looking for A. Now that's the same as having like a 3, 4, 5 triangle. So that would mean A would have to be 40. Or you can use the Pythagorean theorem to figure it out. Okay, so in for A goes 40, and dA dt is 35. All right, so then we isolate dc dt. We get 40 times 35 all over 50. And we can reduce that a little bit, and our answer would be 28. Now look at the derivative to figure out what the units are. C is a unit of length, the hypotenuse, so that would be what unit of length did we have? Kilometers. And T, time, the only time given in the question was hours, so it's got to be 28 kilometers per hour. And there we go. That would be how fast the train and Chantel are, that distance between them is changing. I hope that helped.